Okay. And then I'm going to there we go. Aha. That's weird. Hey. Okay, so for now, can you guys all hear me?
Yes, ma'am.
Okay, good. I'm going to cancel the video in here. The video. Okay, can you hear me? Can you hear me?
Yeah.
Okay. So here is what I'm going to be doing. Okay.
Hey, Scott, you want to know what happened yesterday? Are you about to cook? Are you going to teach us while you're cooking?
I'm not going to be cooking. I'm going to be doing not an experiment, but an example of energy, of thermal energy.
What grade are you in, kid?
Okay, so first thing I want us to do is put this burner right here, the small burner, onto high. So you can kind of see a little bit about thermal, what is it? Radiation. Okay, so you can see how that burner is heating up, right? And what's happening here is I can feel the heat all the way up here. And that's because the heat is radiating up. That's radiation. Okay, so I'm going to turn that off. And I'm going to turn this on. My small burner to high. And now I'm using a metal plate here, a metal frying pan, because metal is one of the most conductive materials there is.
Okay, I just came back and you have a frying pan for some reason.
Yeah, she's cooking.
I'm not cooking.
What are you making?
I'm showing you an example. Shh, quiet. I'm showing you an example of the different types of thermal energy. So again, here, this right here that's making the heat go up, that's radiation. The heat is radiating up. Okay, and it's radiating up onto this frying pan. Now, when this frying pan heats up, I'm not going to be able to touch this because it has conducted energy. This is conduction because the heat is coming from here and it's going to conduct all the way over to here. And that's going to make it so I can't touch this. It's going to be too hot. Okay? As this is heating up, you're going to see what it looks like for convection. Okay, you guys turn off your TVs and your radios and all that, please.
Jessie, she's trying to teach. Stop being disrespectful.
Thank you. So as we watch this heat up, you're going to see bubbles coming up from the bottom and rising to the top. And that is convection. So you're going to have heat energy trapped inside those little bubbles coming to the top and then spreading that heat energy across as it goes. That is convection. So we have three types of thermal energy that are happening here. The one underneath is radiation. The one that makes it so I cannot touch this after it gets hot is going to be conduction. And the one that is showing the heat rising up through the water, the hot bubbles going through the cold water is called convection. I wanted to point out to you that sometimes in the spring, do you ever see like the big puffy clouds that look like cotton balls that are just floating around? Do Do you guys know
No,
what
I
I'm
don't
talking?
go outside.
Me neither, because COVID.
Nobody asked.
You can still go outside and look at the sky. You don't have to stay inside your house. But you know what I'm talking about. You've been on the earth long enough to know about the big puffy clouds that are up in the air, right?
Miss Scott. Yes, yes. But how come when you put ice on like a steel pan, how come like it just melts for some reason, the ice?
Because the pan is warmer than the ice.
But how is it even warm at all?
It's not warm, but it's warmer than the ice, unless your pan is actually at the, okay, you know what temperature water turns into ice? Do you know the freezing temperature of water?
How is there two of you?
I'm on my computer and I'm on my phone.
Oh.
Wow.
Oh yeah, so like Miss Scott.
Yes.
I'm about to expose something.
Okay. Wait, hold on. Go ahead and talk, and I'll be right here.
Wait, what was I saying? Oh, yeah. So you know that kid who joined earlier?
The kid who joined earlier.
Yeah, it was, what was his name? Elias?
Yeah, Elias.
I know who that was.
Who was it?
Try and take a huge guess.
I have no idea.
It was me.
Really?
Yeah, I was doing
For
it
some
on
reason,
my...
I thought you were related to him because you were muted the whole time, and right when he left, you started talking.
Yeah? No, I was doing it on my phone.
Okay, can you see how there's steam rising up?
Yeah, but yeah.
Okay.
Yeah, you're
I
boiling
was...
water.
Let me explain something to you. Back to those clouds that I was talking about.
Mhm.
Those clouds, those big puffy clouds, are because when air is on at ground level, it's in bubbles. You can't see the bubbles, but they are in bubbles. And so bubbles will often heat up, and then they will float up because heat rises. They will float up into the air, and then because they are exposed to cooler air as they rise,
Miss, someone's in the
moisture.
waiting room. Miss Scott.
Oh
Miss
yeah?
Scott, don't do it. It's probably Jesse.
Hold on.
No, it's not.
How do you
Where
know
is
they're
it?
in the waiting room then?
Because they texted me.
Miss Scott.
I don't see anybody in the waiting room. I don't see anybody in the waiting room, and the phone did not make the waiting room noise. So I'm in the middle of trying to teach something, Jesse. Will you let me do it, please?
Yeah.
Okay, so I want you to look at this. Do you see what's happening here?
Yeah, there's steam.
And there's bubbles at the bottom.
Mm-hmm.
Those bubbles are hot, and they're rising to the top, and they're going to come to the top and spread out and conduct energy.
What?
They're going to...
What do you think would happen if you just had a pot boiling water and you just drank it?
Jesse, I'm trying to figure out what would happen if I could get through a complete sentence without you interrupting me right now.
Dang.
Come on.
Okay, so I was in the middle of clouds with the bubbles that were floating up to the top, and as they float float up into the air, they're exposed to cooler air that has moisture in it, and the moisture starts to condense, and that's why it forms a cloud. So all of those clouds that are up in the air used to be bubbles on the ground. That's convection in our weather. This right here on the bottom with this boiling water right here is convection in the pan. Now, if I were to touch this right now, it would be hot, too hot for me to touch, like for long. I can touch it for like a minute, but it's warm. It's really, really warm. And it's just getting warmer. So remember, the heat from the stove is radiating up. That's radiation. The heat on this handle right here is from conduction. And the heat from the boiling water is convection. Okay, and I'm going to show you that in a graphic when I get back. But what I'm going to show you, hold on, I'm going to take this glass and I'm going to put some hot water in it. I'm going to use my heating pads because this is hot. Ouch. I'm going to pour some of this water in here. Woo, woo, woo. Hot water everywhere. God bless. Okay. So now the next thing I'm going to do, whoa, hello, is I'm going to show you the temperature differences between this water here and this water here. This has been in the refrigerator. This is the hot water that I just made. So we're going to give it just a minute. You can see the water, the red strip is way the heck up there. Now, the temperature of water, boiling water in Celsius is 212 degrees. And in Fahrenheit, in Celsius it's at 212 degrees. In Fahrenheit, it's 100 degrees. For freezing water to turn into ice, at Fahrenheit, it's 32 degrees. And at Celsius, it's 0 degrees. So right now, our thermometer shows that it's just above freezing. It's at about 5 degrees Celsius and about 40 degrees Fahrenheit. And this right here, it is about 88 degrees Celsius and 100 degrees or 190 degrees Fahrenheit. So it's really hot. So what I'm going to do is I'm going to put food coloring in each of these glasses, and I want you to tell me the difference between what happens in one versus what happens in the other. So this is the cold water, and this is the hot water. Can you see the difference?
Yeah.
I made them.
Okay, so let's go talk about it. Let me get my phone and we'll talk about it in just a sec.
Miss Scott, you're muted.
Thank you. So what's the difference between the cold water and the hot water?
Hot water's hot.
Yeah, but what happens with the cold?
Cold.
You guys are so brilliant. But with the food coloring, what's the difference between what happened in one versus what happened in the other?
One bubbled up.
Bubbled up? What do you mean? So when I dropped it into the hot water, what happened to it?
It spread it faster.
I
It spread
couldn't
it out
see.
faster.
I got kicked.
Okay, so it spread it out faster. And when I put it into the cold water, what happened?
It sat there.
Yeah, it just kind of sat at the bottom, right? Why did that happen? Can you tell me? Remember what the definition of thermal energy is? Can you remember from our thing? Hold on. That's kinetic. I don't want that. That's temperature is how hot or cold something is, but really the reality of heat is how fast the molecules are moving. So the hotter something is, the faster the water molecules or whatever molecules it is are moving. So with the water, the hotter the water, the faster the molecules are moving around. So that's what results in having the food coloring get spread around a lot faster. And I tell you, if we go back into the kitchen and look at the cold water, in about 10 minutes, it's going to look pretty much like the hot water did. It is going to spread around, but it's going to spread around a lot slower. Does that make sense? Huh? Hello?
Huh? I did this once at my old middle school in science class.
Oh, yeah?
Yeah.
Did you learn from it?
No, not really, because it was like the first few days of school, so they were just like explaining a few things.
Ah,
And then it immediately went from, oh, we're learning about this to, oh, it's time for sex ed.
wow, that's a
Yeah.
big jump.
Yeah,
Okay,
that was
so there's two things that I want you to know from this. One, that the hotter something is, the faster its molecules are moving, and the colder something is, the slower its molecules are moving. And two, the difference between conduction, radiation, and convection, which I just showed you with that pan of water, right? That the radiation was the heat coming up off of the stove. The conduction was the heat traveling from the bottom of the pan to the handle of the pan. And the convection was the heat being forced from the bottom of the pan through the cold water to spread heat throughout the water. All right? That's what I wanted you to get from that. So I've recorded it. If you need to look it over and, look at it again just to make sure that you got it all, please do so, okay? I'll have it posted tonight.